everyone. Myself, Shruthi Poonacha, heading the Department of Computer Science. Here I am to introduce the concepts of program development life cycle, and also I'm here to brief you with regard to the simple introduction to C programming language to the first year students. So the structure of the session would be the introduction to the concept. Next, the steps involved in the program development life cycle. And next would be the discussion on a few of the program designing tools like algorithm, flowcharts, and pseudocode. And then an introduction to the programming languages and a brief introduction to C programming language. So this would be the structure of the session. So now majorly I'll be discussing the program development life cycle. So when discussing the program development life cycle, first let us take an example wherein we are moving in a car and suddenly I hear a strange noise in the car. So what do? I stop the car and try to find out where is the problem. I try to find out the problem. So if possible, I'll be able to, if I'm able to really clear the problem, I do it and I move across. Otherwise, I take it to a mechanic for the repair. So what does a mechanic do? Once he analyzes the problem, he tries to repair the vehicle, and how does he repair? He uses few steps, few methods to repair the vehicle, and then sets it right and then gives it to you. But if the issue is if it is a complex problem, so it requires a methodical approach to find the right solution. So similarly, when we take a computer program or maybe a mathematical problem, when it is taken to be solved in a computer, so we need to apply few of the problem solving techniques. So initially what we do in the problem solving technique is that we first precisely identify what the problem is and then end with a complete working solution, that is something like a program or maybe a software. So this is the way how we use few methods to solve a particular mathematical problem. So we generally know that computers are used very widely in all the different types of fields, in all the different types of applications in the recent days. So it is a powerful, versatile machine capable of performing multitude different types of tasks. So for a computer to perform with the many tasks exactly in the same manner as it is being told, it is the responsibility of the user to instruct the computer in a correct and a precise way. A wrong or a ambiguous instruction will lead to ambiguous outputs. So in order to instruct the computer correctly, the user first of all should have the clear understanding of the problem that is to be solved. So first of all, the problem should be well defined and a method of solving it is developed. Then the computer is instructed to solve the problem. So when we attempt to write a computer program, it is necessary to formulate or define the problem in a precise manner. So now, who are the program solvers? So the computer cannot solve a problem on its own. So it is the user who has to provide the step-by-step solution of the problem to the computer. So now let us see the steps involved in the program development life cycle. First, the problem should be analyzed, that is analyzing the problem. Next is the problem definition. Next, the problem design, coding and implementation, testing and debugging, and then the documentation and maintenance. So next here we just see the diagram of how these stages flow. So initially the user has to analyze the requirement and then the program should be designed. Once the program is being designed using few of the tools like algorithms or maybe the flowcharts, then the coding for the program is done, then the documentation and maintenance is done, and then that is maintenance is done when the user uses the programs. So now let us discuss each of the stages in the program development life cycle. So the first stage here is that analyzing the problem. First stage here is to analyze the problem. So here what is done is we try to understand the problem to be solved. Then we'll look into the different ways of solving the problem. Now let us look into the various steps involved in the program development life cycle. So the first step involved is to analyze the problem. Here the major thing is that we try to understand the problem to be solved, and then we look into the different ways of solving the problem and to evaluate each of these methods. The idea here is to search an appropriate solution to the problem, and the end result of this stage is a broad overview of the sequence of operations that are to be carried out to solve the given problem. The next step involved in the development life cycle is problem definition. So here a clear problem statement is to be provided. That is nothing but the objective of the problem should be defined. That is, the complete knowledge of the problem is to be specified, and all the inputs and outputs should also be specified. Say for example, if you are given some numbers and then you are told to perform some particular operation, at the end of the problem definition you need to define, say for example, to find the average of two numbers. So this is the objective of a particular program. So by the end of this stage you should be able to define what exactly the problem should do. That is the second stage. So the next stage is the program design. So here the overview of the sequence of operations which is the result of the previous stage is expanded to form a detailed step-by-step solution to the problem under consideration. So the software developer will make you, in order to develop the set of instructions or to develop the set of codes, will be making use of the tools such as algorithms and flowcharts to define the problem. So the next stage, once the algorithm or the flowchart is being designed, so the next stage involved is coding and implementation. So here it is nothing but the conversion of the detailed sequence of operations into a language that the computer can understand. Here each step is converted into its equivalent instruction or instructions in a computer language which has been chosen for implementation. So okay, here since I'll be briefing you regarding the C programming language, what I can say is maybe the coding is done using C programming language. So it is a high level language. So once the algorithm or once the flowchart is being developed, so I'll be using the C programming language to develop the code or the solution for that particular problem. So next is the next stage involved here is the testing and debugging. So testing is nothing but checking for the errors syntactically and semantically. Syntactically means to say to check whether a sentence is grammatically correct, and semantically means to say that it is to check whether the sentence has a valid meaning, whether the sentence, the statements what you have developed has a valid meaning, called as semantical verification. And syntactical verification is to check whether the sentence is grammatically right. So when we are using the C programming language, there are certain syntaxes and semantics that is to be followed with regard to that particular language. So all the syntaxes should be maintained when you are writing the code or set of statements using the C programming language. Okay, so the program created should be tested for various different parameters. The program should meet the requirements of the user, and it must respond within the expected time. So within a certain period of time, the output should be obtained. That is what it means. So that is why we test any set of code with various different parameters. Okay, and it should generate the correct output with all the possible inputs, whatever has been specified. Accordingly, the output should be obtained. And the one more step involved during this stage is debugging. It is nothing but checking for the errors in the program, which is to be detected, and it needs to be corrected. And this stage is also called as program validation. And the last stage or the step involved in the program development lifecycle is nothing but the documentation and maintenance. Here, what is documentation? This documentation helps the user and the people who maintain the software. This ensures that the future modification, if required, can be done easily. So it is required during this, or it is during mainly this documentation is mainly required during the redesigning and the maintenance of a particular set of program. And what is this maintenance? Maintenance is nothing but updating and correcting the program for a changed condition. For a changed condition, you update the program and you do some corrections. So if any enhancements are found in this phase, all the phases which we have gone through is to be repeated to make the enhancements. So that means in this phase, the program solution is used by the end user. So if the user encounters any problem or wants any enhancement, then he needs to the all set of phases are to be repeated to solve this particular problem. And if any enhancements required, all the stages needs to be repeated. Okay, so these are the steps involved, that is the 6 steps involved in the program development life cycle. So now specifically, let us look into few of the designing tools that which is used. So the majorly, whenever a problem is given, the first step involved there is to write the algorithm for that particular problem. So what is an algorithm? So why is that the first step is to write a algorithm? So how do we define this? So algorithm is nothing but a set of sequential steps, usually written in English, to solve a given problem. Okay, it is simply the sequential steps. That means the step-by-step solution to a particular problem. That is what, in simple to say, it is nothing but the step-by-step solution given to solve a problem, and those steps are being written in simple English. So that is called as an algorithm. So when you write an algorithm, there are certain set of features that is to be noted. So when an algorithm written, it should be finite. The algorithm written should be finite. That means to say, an algorithm must terminate in a finite number of steps. That means to say, your algorithm should not be very, very lengthy. It shouldn't be simply, you should not go on dragging the steps. So within finite number of steps, your algorithm should get over. This is the first feature of an algorithm. So the next feature for an algorithm is definiteness. Okay, each step in an algorithm should be precise and it should be unambiguously stated. Okay, that means to say, it should be all the steps that which is involved should be clearly, it should be defined. That means it should be unambiguous. Next step is effectiveness. So each step must be effective in the sense that it should be easily convertible into the programmable statements. The steps what is being written, the steps should be written in such a way that once these algorithm steps are looked into, it should be easily converted into a programmable statements, and that too within the finite amount of time. Within some particular amount of time, the steps what is been written in an algorithm should be converted into the programming language. And the next feature to be followed is generality. So the algorithm must be complete in itself. That is the major requirement, that such that it can be used to solve the problems of a specific type for any set of input data. And the last step is the input or the output. So each algorithm must take one or more quantities of input data and should produce one or more output values. It should take one or more input values data, and you should get one or more output values. So these algorithms which is written in the English language are also called as the pseudocodes. We also see what the pseudocode is. So this is what an algorithm is, which is a tool used in the program designing phase. I'll just give you an example of how the algorithm works. Suppose that we want to find the average of three numbers. Okay, we want to find the average of three numbers. So the algorithm would run like this. The first step is to read the three numbers. I want to find the average of three numbers. So the first step involved here is to read the numbers A, B and C, and then I find the sum of the three numbers A, B and C, and then I divide the number by 3, then store the result in a variable called as D, which will hold the result of the sum of the three numbers, and then print the value of D, and which ends the program. And the next step is to end the program. So this is a simple algorithm written in simple English to find the average of three numbers. So the next another tool involved in the program designing phase is the flowchart. So now what is this flowchart? A flowchart is a step-by-step representation or a diagrammatic representation of the logic paths to solve a given set of problem, or in simple to say, it is nothing but the pictorial representation or a visual representation or a graphical representation of an algorithm. Okay, it is simple. Simply you can say it is a pictorial representation of an algorithm is referred as a flowchart. So here the methods used, or here in this specifically the few symbols are being used to solve a given problem, and it helps in a great deal to analyze the problem and to plan its solution. So a flowchart, when translated into a proper computer language, results in a complete program. So normally we see what are the various different symbols that has been approved by the international standard of organization, that is ISO has approved with few of the symbols that can be used in a flowchart. So the first symbol majorly used in a flowchart is the symbol of a oval. Okay, wherein it is used to indicate the start of the program and to stop the program. So you want to begin the program, you since it is a pictorial representation of the flow of the steps of algorithm, so you say begin the program. When you begin the program, you start it with the oval shape. You say start and then you encircle it with a oval shape. So that is how you begin the program using a flowchart. So the next symbol used in a flowchart is the parallelogram. Okay, so this parallelogram is the input and the output indicator. Okay, it represents the input and the output operations. The statements like input, read and print are represented within these parallelograms. The next symbol used here is the rectangle. So rectangle is used as the process indicators. It is called as the process indicators, which is used to indicate any set of processing operation such as arithmetic operations. Then the next symbol used here is the rhombus symbol, or you even refer it as the diamond symbol, which is called as the decision makers. Okay, so it is used to indicate the step of decision making, and so it is called as a decision box. So they are used to test the conditions or ask questions depending upon the answers. So the appropriate actions are taken based on the decision being taken. So the decision box is been, the picture of the decision box has been shown. The next symbols that which is being used here in the flowchart is the flow lines. Okay, so flow lines indicates the direction to be followed in a flowchart. So in a flowchart, every line must have a arrow mark on it to indicate the direction of the flow of the set of steps. So the arrows may be in any direction. Okay, so it could be towards downwards or upwards or towards the sides. So you have all the the arrow marks looking in facing all the sides. The next symbol used is the on-page connectors. Okay, they are the on-page connectors, which are wherein you have the circles that which is used to join the different parts of a flowchart, and these circles are called the on-page connectors. The use of these connectors gives a neat shape to the flowchart. So in a lengthy or a complicated program, a flowchart may run into several pages. So the part of the flowchart on different pages are to be joined with each other. So the parts to be joined are indicated in the circle. And the another symbol used in a flowchart is the off-page connectors. So this connector represents a break in the path of the flowchart, which is too large to fit on a single page. So it is similar to the on-page connector, which was discussed right now, just now. The connector symbol marks where the algorithm ends on the first page and where it continues in the next page. Okay, so these are the various different symbols being used in a flowchart. So now let us look into an example of a flowchart. The example is to find the mean of n numbers. So here we see the initially in the beginning we see the oval shape, so which represents the beginning of the program. So I use the word called as start, and in the end you can see the oval shape, which shows that it is the oval symbol being used to stop the program. So let us start. So initially you start off with the oval shape, then followed by with the initializing of the values. So initializing of the values is being made within a rectangle shape. So their variable sum is being assigned with the value 0, and another variable called as I is being assigned with the value 1. So next the two symbols that which is used are the parallelograms, which are nothing but the inputs to the program. So I input the n numbers. So for how many terms I need to find the n. For how many numbers I need to find the n. To keep the count of this, I use a variable called as n, and the other variable used there is the next is the x. Okay, so they are represented using the parallelogram, which is nothing but the input. So and then you can see the flow lines. You have the arrow marks flowing downwards. So the next step flowing down is to do the processing or to perform the arithmetic operation. So there within the rectangle, which refers to the processing, wherein I say sum is equal to sum plus x. Okay, and then I is equal to I plus 1. Here I perform the arithmetic operation, because of which I am using the processing within the rectangle shape. Then you have a flow line moving down with the symbol of a rhombus, making some decision there. Okay, in the decision box I say you perform previously you perform sum is equal to sum plus x, and then you say I is equal to I plus 1, and then within the decision box I check for the condition whether I value is less than or equal to n. So when you check, or when you're making the decision, you have two sets of output coming out. So maybe I is less than n. If it is true, you have certain set of steps to be executed, or if it is false, you have the steps below that is to be executed. Okay, so when I is less than n, if it is true, yes, the value of I is less than n, yes, it is true, then what happens? You have a symbol that is a connector there which says A, wherein it takes you back to the input. It takes you back to the input, and then you perform the operation again till the value of I becomes greater than, or till the value of I becomes less than n. You go on repeating the steps. Okay, that is for the true condition. In case if the value of I is greater than n, so in that case what happens? If the condition is false, that means to say the next step is being executed, which is a arithmetic operation wherein mean is equal to sum by n. You find the sum the average of the sum, that is from the n values, and then the output of the mean, that is output of the program, will be displayed on the display box, and then you come out of the program. These are the steps involved in developing a flowchart, okay, wherein you do the representation of the flowchart using the various different symbols, okay, that which is being approved by the ISO. So this is your program designing tool, which is called as a flowchart. Okay, so now let us look into another designing tool called as a pseudocode. Okay, so this pseudocode, it is neither an algorithm nor a program. It neither looks like exactly like an algorithm, nor it is called as a program. Okay, it is simply the abstract form of a program. It consists of the English-like statements which performs some specific operation. So it is defined for an algorithm, and it does not use any graphical representation here, just like in a flowchart. Okay, in pseudocode, the program is represented in terms of words and phrases, but the syntax of a program is not strictly followed at all. So the advantages of the pseudocode are that it is easy to read, it is easy to understand, and also it is easy to modify. So now I take a simple example of writing a pseudocode to perform the basic arithmetic operations. So to perform a basic arithmetic operation, the inputs required are n1 and n2 are the two numbers that which is to be given, that is the inputs to be given. So read n1 and n2, and then first initially you find the sum of n and 2, that is sum is equal to n1 plus n2, and you want to perform the difference, or you want to perform the subtraction. So you say difference is equal to n1 minus n2, and to perform the multiplication, n1 into n2, and to form the quotient, you say n1 slash n2, and then you need to print. It is simple. This pseudocode, it consists of English like statements which perform the specific operations. Okay, so this is a kind of representation what is used during the program designing phase. Okay, now these are the various different stages that which is being involved in the program development life cycle. Now let us move on to a brief introduction to the programming languages. So now, what is a programming language? How do we define a programming language? Is that the programming is an act of instructing the computers to carry out the tasks, and it is also referred as coding. It is simply the set of instructions. It is simply a set of instructions given to the computer to perform some certain set of tasks. Okay, so now how do you right now we have looked into the various steps or the stages involved in the program development life cycle. So we have seen how the problem has to be solved. Okay, we have used the algorithm, or we have used the flowcharts, or maybe we have used the pseudocodes to develop a solution to the problem. So all of these have been written in a simple English. Now, so this is for the understanding of the user. The user has understood the program, and this is used for the understanding of the user. But now the solution what we have got has to be programmed. So how do we program this? This is done using maybe the simple language. What we are looking into is the C programming language. Okay, so this C programming language is nothing but a set of instructions given to the computer to carry out or to perform some task, and that is called as coding. Okay, so these sequence of instructions that which is been given to the computer is also called as the computer program. Okay, so the machines have their natural language, like what humans do. We humans we understand the language in the form of English. Similarly, computer understands the coding what we have written in the form of the binary codes. That means to say the computer can understand only zeros and ones. So 1 is referred as on state and 0 is referred as the off state. So to communicate with the machines who understand only binary, so we need to, what we do is, first thing is that we first write the codes in the English. Okay, so then to convert these programming codes which is written in English, we require the translators. So it is the responsibility of the translators who translates the English written language or English written instructions into the binary form which the machines can understand. So in C we call it as the translator is called as a compiler. So it is the job of the compiler to translate the high level language into the low level language which the machine can understand. So now a brief introduction to C. In simple, I give you the brief introduction of how this programming language called as C works. So C is a general purpose high level language. Okay, it was originally developed by Dennis M. Ritchie to develop, mainly it was used to develop the Unix operating system, and it was developed in the Bell Labs. In 1978, Brian Kernighan and Dennis Ritchie, they publicly made the C program available in the market. And then C is the successor of the language called as a B language, which was developed in 1970s. And in the year 1988, this language was formalized by the American National Standard Institute, that is called as ANSI. So normally we refer it as ANSI-C. Okay, so further to look into the C program structure, or the structure of a C program. In simple, this structure, initially you will be starting the program with the preprocessor directives, followed by the global declarations, then followed by the function definitions. So within the function definitions, you write the certain set of statements, that is a certain set of logical statements which helps in solving the problem. So now here is an example of a simple C program. Okay, so the first line says hash include stdio.h, which is referred as a preprocessor directive. So it is a preprocessor directive. Initially you start the program with this preprocessor directive, followed with the global declaration which says int x. Int is referred as a data type and x is a variable. So your variable x is of the data type int. Next followed by the function declaration. So where you have the int main as the function declaration. So this is being followed with the local declarations, that is the variables that which is being defined within the function. So this variable is restricted to be used within that particular function. And then this local declaration is being followed with a certain set of statements. Okay, so this is how the simple C program looks like. So now we'll see what the preprocessor directives are. So to begin with, the preprocessive directive, it begins with the hash symbol. So it instructs the compiler to perform some transformation to a file before computing. For example, the statement says hash include stdio.h. That means it adds the header file stdio.h to this particular program. And then .h is referred as the header file, and then stdio.h defines the useful input or the output functions that can be used within that particular program. Okay, so next you have the certain set of declarations. So when a variable is declared as global, that particular variable is visible throughout the program. That means to say, throughout the program the particular variable which is defined as global can be used. It does not have any limitation. Okay, throughout the program, anywhere the variable that which is declared as global can be used. It describes the data used throughout the program. And then you have one more declaration, that is the local declaration, which is visible within a particular function. That means it is limited to a function. So within that function the local variable can be used, and it describes the data used within that particular function. So these are the two various declarations being used, that is a global declaration and the local declaration being used. So next part of the program is the main function. Every C program has a function called as a main function. So every program will begin with the main function. So the header for the main is int followed by main, int main. So the program is the sequence of statements that should be written within the curly brackets. So after you say int main, you start writing the set of statements. So those statements should be within the curly braces, and then the statements are executed one at a time and following to main to the one before the one which is specified there, that is a closed curly brackets. So the comment section, for the comment section, that means the comments are being written in every program, which means to say it communicates to the user what each logical step means. Okay, it is written in simple English, and that will not be processed by the compiler. The statements written within the comment section will not be processed by the compiler. So those comments are written only for the understanding of the user. So those comments should be within the symbol what is being specified here, that is /*. So it should begin with a slash and a star, followed with the comments to be written, and then it should be again closed with a star and a slash. Okay, so this is a simple introduction of how a C programming looks like. So the detailed study of the C programming language will be shown in the next videos that is to come, and thank you.